Good afternoon. In today's video session, I would like to differentiate between thermodynamics and heat transfer. Now, thermodynamics is something which is related to the energy and the properties of the system. Consider this as a system, and this system consists of a substance, and the system is subjected to some input energy, E input, and the system will result in an output of some energy, E output. Now, when you are applying some energy to the system will have substance. The properties of substance are changing. And these properties are resulting in an output of energy, that is E out. We are saying this is a thermodynamic system because either E input or E output is something which is related to thermal energy. And because of the application of thermal energy onto the system, the properties of systems are changing. Now, this system, when it is been interpreted in terms of energy transfer, then it is called thermodynamics. So in thermodynamics, we are talking about energy transfer one form of thermal energy to other form of energy, and one of the energies is completely thermal energy. One of the energy is thermal energy, and also this energy is being related to the thermodynamic properties. One of the energies is related to thermodynamic properties. So, example, if you take a turbine, some substance, it's a flow system. The turbine is a flow system. Some mass input and at higher pressure, Pi, is being entered into the turbine, and this turbine is performing some work, and the output is MO at P output. The pressure is being dropped. So this is a thermodynamic system, and the equation for the especially these thermodynamic systems will follow three laws. That is zeroth law of thermodynamics, first law, and second law. Now, according to the first law, delta Q, that is heat input or output, results in raised internal energy plus some work. And this W is integral P dV. And P and E are the properties of the system. So the behavior of the properties of substance and thermal energy and mechanical energy is correlated, and together it has discussed as subject of thermodynamics. That is one thing. Now, what is heat transfer? Now, heat transfer does not involve the amount of work. It completely neglects the work done on the system. The only thing it is involved is heat transfer. That means the energy input or output and the properties of system. So Q and the Q input or Q output and the properties. And here the substance which we are considering are of three types. One is solid, second one is liquid, and third one is gas. Now, when you are trying to apply the heat on a solid, You are trying to observe the temperature distribution of the solid, and it is called conduction. In heat transfer, you are trying to study the conduction, and if you consider the substance as a liquid, then you apply the heat, the temperature distribution will cause because of the mixture because of the density difference. It is called convection. And third one is radiation. And radiation is applied to heat a body or an object by a distant source of heat. I mean, sun is heating the earth, atmosphere. That is radiation. So there are three things that is mainly differing thermodynamics and heat transfer. Thermodynamics basically involves the energy transfer, one type of energy to other type of energy, and the energy, one of the energy could be a thermal energy, and other could be a mechanical, electrical, or something else. And whereas heat transfer involves only the heat transfer, and because of the application of the heat transfer, what is the changes in the properties of systems? That is what is the difference between a thermodynamic systems and a heat transfer. This is what I would like to discuss in this video session, small video session. Thank you very much.